Here we go, my friends. So let's just simplify some square roots, just to kind of practice here. So first one, nice and easy, nothing too crazy. Again, I like to use my perfect squares. The biggest perfect square that goes into 48 is 16. And it goes into there, of course, 3 times. So what's the square root of 16? 4. So we are going to be simplifying some radicals today. So just reviewing that again. Biggest perfect square that goes into 12, 4. Now, what's the square root of 4? 2. And we're going to multiply that, because we're product between everything here. Multiply the 2 with the 6, so 2 times 6, 12. Got it. Okay, what's the biggest perfect square that goes into 75? 25, I heard it. Goes into there 3 times. So hopefully from here, of course, we can get our final answer. Square root of 25, 5. What's 5 times 2? 10. So we have 10 root 3. And here we're getting fancy. What are you putting for the square root of negative 36? 6i. So a little review. We're going to talk about imaginary units today, but that's really about as wild as they get. Any questions on the simplifying? Just practicing. Okay. All right, so definition of a complex number. For all real numbers, a and b, a plus bi is the complex number. Now the order does matter, okay? So the order must be the real part and then the imaginary part. So meaning, if this is your complex number, you have to write it in that order. If you give it to me like this, the imaginary part first and then the real, no dice, my friends. That would be one of those little, minus a half, nobody wants that sort of situation. Now, common values of I. We should know what these are. Of course, I represents that square root of a negative. Now, we should put a number in there to hold the place. It's really the square root of negative 1. I squared comes up a lot of times in some of these problems. So I'm like, well, that's easy enough to get. If I just square both sides to turn that into a squared, square root cancels. I cubed comes up a lot of times. Again, I would just go to I squared. If I put an I on this to make it I cubed, put an I on here. And an easy way to get I to the 4th, I'm just going to jot it down underneath I squared, negative 1, negative 1. So there is a pattern here. Your even exponents rotate between negative 1 and 1. So I can tell you I to the 6th, negative 1. I to the 8th, 1. I to the 10th, a negative 1. I could do it all day. Same with the i's. I to the 5th, positive I. I to the 7th, negative I. I to the 9th, positive I. So on and so forth. Also pull out your calculators. If you look above the decimal key, there is an I there. So if you're like, oh man, I can't remember what I to the 4th is. Hit second decimal button, raise it to the 4th, and it will tell you it is 1. So there's no reason to ever get any of these wrong, because of course you can always use your calculator to help the cause a little bit. Did we know where the I button was on the calculator? I hope, I pray, I hope. Use that to help the cause. Okay, so we're going to do some operations with these. We're going to add, subtract, multiply, divide. Adding and subtracting, super easy. We're going to have some equations too. So when you have your equation, I always kind of think of this as like terms, so to speak. You're going to set the real parts equal and the imaginary parts equal. So just keep what I kind of think of like terms. Keep the reals together, keep the imaginaries together. Same for adding and subtracting. You're going to add the real parts together, and then they do the imaginary. Same for subtracting. So again, I always just think like terms. No mixing and matching. Pretty easy, pretty common sense. See, even though it looks like long notes, just like that, we're already through the first page, and the next page goes pretty quick. Find a real number A and B so that the equation is true. So piece of cake, real numbers together, really that's the real. This is the real because there's no I on the A, so A equals negative 10. That really was hardly worth me writing anything down. Okay, then I'm going to do the imaginaries. Well, they want you to solve for B. Really what happens to the i's on either side? Cancel. B equals 6. Now, would you really have to write this first green equation, or could you go right to the answer? Right to the answer. Yeah. Okay, same thing. Reals, because there's no I. So I am going to have to do a little mental math here. Clearly, A is 6, add 1 over. Love this stuff. Okay, and then let's do our imaginaries. So our B plus 3i and 8i. Now, of course, same thing, the i's are going to cancel. A little mental math, B is what? 5. See, love the imaginaries. Can't beat it. So there's the equations. Can't beat that. Let's do some more simplifying. Write the complex number in standard form. Remember, that is the real plus the imaginary. That's what standard form means. So, of course, let's just do a little simplifying. What's the square root of negative 25? 5i. And I'm just going to check. Real, imaginary. Yep, got the right order. Good enough. Love it. No work. Okay, same thing. Now, I'm going to take the I out for the negative. And just like in the beginning, I have a good feeling we can simplify the square root of 27. I'm going to use 9 and 3. And what's the square root of 9? 3. So I'm going to make this 3i square roots of 3. Now, this is just me being nitpicky. You know, I can't help myself. I don't love that answer, the form of it, the order of it, but I know Algebra 2 lets you leave it in that order, so I would not mark it wrong. But technically, it should be A minus B I. Technically, the I should always be at the end, but I know sometimes that's tricky and maybe it looks like it's under the root, and I know Algebra 2 lets you leave it this way, but this is really your best answer. And that's how I'm going to write them, with the I's at the back, but I'm not going to freak out if you give me that previous one, because I'm going to blame that on Algebra 2. Okay, easy enough. What do you have for this? What's square root and squaring do? Cancel. So final answer. So nice. And, okay, now you might be looking at this and be like, say what now? Remember, A plus B, I. No I squared can be in your answer. Nothing beyond just I. What's I squared really? Negative 1. And again, worst case, if you don't remember that, punch it in your calculator. Now, I would nitpick that. There's still one little glitch on there that we don't like.
Wrong order.
Wrong order. I need to flip it around so I have the real and then the imaginary. Any questions on that? Okay, I love the next one. Same thing. Again, we just have to know what I squared and I cubed are. You already told me last one, I squared is negative 1. What's I cubed? Negative I. Now, let's just simplify. Negative 4, negative, negative, positive. Just take a double check there. Are you in the right order? Yep, good enough. Okay. Got it. All right, let's take a look at this guy. 1 over 2i cubed. Well, I'm going to, of course, cube everything underneath. What's 2 cubed? 8. And then I cubed. And as always, you can't have anything beyond just I to the first power. So I'm going to rewrite that I cubed as negative I. I'm going to make this negative 8i. And the only thing I would say, I mean, you can leave it like that, but usually you don't leave a negative in the bottom of a fraction. I'm just going to kick the negative out front, make it negative 1/8 I. So just for funzo, what would be the real part of your answer? Do we have a real part? No. What holds the place if you don't have it? 0. So we have 0 for the real, which is, do you have to write 0 minus 1/8 I? No. I'm just pointing it out that we really have 0. All right, any questions on that guy? See, easy stuff, easy stuff. Love the imaginaries. Okay, find the indicated addition or subtraction. Now, same thing, like terms. I'm going to do the reals. 5 plus 6. I can mentally do that one. And then, of course, I'm going to do your imaginaries. 1 plus negative 2i. We are in the right order. Real, imaginary. Circle it up. Go to the next. Same deal, real. So 8 minus 4, we're subtracting. And then let's do our imaginaries. Negative I minus negative I. What does that result in? Do we have any i's left? No. Do I need to put 0i? No, you can if you really wanted to be dramatic about it. but we're just going to end up with 4. So adding and subtracting piece of cake like terms together. The only reason we're doing the next one is because who doesn't love a fraction? Now, you guys already look angry. You can do the fractions in your calculator, but we should be able to do it in our heads. Okay, so I'm going to do the real parts. Now, keep in mind that negative applies to everything. So negative 3/4 is my real part, and I'm subtracting 5/6. What's your common denominator between 4 and 6? 12. So I'm going to have to times this by 3 to get it to 12s. I'm going to have to do this by 2. A little multiplying, so negative 9 12ths, 5 times 2, 10 12ths, piece of cake. Could you have done that in your calculator? Yeah? No? Okay, let's do the imaginaries. So don't forget the negative applies to this, so negative 7/5 I minus negative 1/6. And what's your common denominator for 5 and 6? 30. So I'm going to multiply by 6. Multiply this by 5. Again, you could do it in your calculator, but we can handle it, I think. 5 times 1, 6 times 5. All right, total that up. What's negative 42 plus 5? Negative 37. So we have negative 37/30ths I. Never want to miss an opportunity to review fractions, right? Nobody seems as excited. You can do it in your calculator, but we should be able to do it by hand. Any questions on those? Okay, moving on. Write the conjugate of the complex number and find the product. So we're going to do some multiplying. And this is going to help us when we get into division. Now remember, conjugate is the same thing except you switch the sign in the middle. So 5 minus 3i. So for this one, of course, negative 6 plus. And then it wants you, of course, it says to find the product of these. So we're going to multiply these together. Now here's what's significant about this. When you multiply conjugates, what happens to the middle terms? Cancel. So we don't even waste our time. We're going to do 5 and 5. 3i negative 3i. 3 times 3, I and I. And here's the nice thing. That turns into just a nice single, plain, boring number. Because what's I squared really? So you have really plus 9 here, so you end up with 34. Because remember, your I squared is negative 1. So that is significant. I'm going to use this to help me simplify when we get to division, the conjugate. But for now, we're just practicing. Now, same thing. We want us to multiply them. Okay, all right. Now, same spiel. The middle terms are going to cancel. So negative 6, negative 6. I'm going to skip the middles. Positive, negative. Square root of 5, square root of 5. I times I. So what is your best final answer? A plain, boring number. 41. Because remember, I squared is really negative 1. Calculate that out, we get 41. So any questions on that? So again, significance about conjugates, because we're going to use these coming at us here in a minute, is that when you multiply them, you end up with just a nice, plain, boring number, no I in your final answer. Now, last thing you have to do on this guy, not that this is really a trick, but you should always deal with the negative first. So meaning I'm going to rewrite this as the square root of 2i. Always take the I out first or you'll miss the sign potentially. And then of course it's conjugate, 3 plus. And now same thing, I'm going to FOIL them together. 3 and 3. I'm going to skip the middles. Negative, positive. Square root of 2, square root of 2. I and I. And what easy, simple, final numerical answer do you get for this one? 11. So any questions on the conjugate? Because we're going to use those in the next couple problems when we get to division. All right, so perform the specified operation, write the result in standard form. Now remember, standard form is just that long-winded a plus bi. Now, just like I said, here's the deal. You have to always take the i's out first, and I'm going to show you why in a minute. So I'm going to rewrite this square root of 5i square root of 10I. Now I'm going to multiply. 5 and 10, of course, 50. I and I. Now we simplified the square root of 50, I believe. I know, maybe not. I know we did 75. 25 and 2. So I'm going to have 5 square roots of 2. I squared, of course. So what's your best final answer? You got it. Now here's the deal. And you might have less work than I did for all of that. Here's the deal. This is going to pain me to write it. A lot of times I'll have kids be like, oh, I'm just going to -5, -10, 50. Are you going to get the same answer? What are you going to miss? The negative. So that's why I said you have to always deal with the I first if they haven't done it. Otherwise you miss a sign. Okay, that's my spiel there on that one. All right, this looks pretty plain, boring, nothing exciting. Looks like they just got to do some foiling. Not conjugate, so gross, I got to do the full FOIL, but not the end of the world. 6 times 2 minus 18I minus 4I plus 6I squared. So of course, nice and easy, we can do our middle terms together. We'll combine those. For the 100th time, it feels like I squared is -1, -1 and 6. So I'm going to combine 12 minus 6 together. -18 minus 4. Make sure I've got it real imaginary. I do. Good to go. Any questions on me? Just some plain old boring foiling. Okay. C. Well, yeah, look at that. Same thing. Looks like we just got to do some distributing. -18I. -3, -1, positive, I and I. Again, I squared is -1. What is your best final answer in the correct order? You got it. Put the -3 first, minus 18I last. Any questions on that? All right, cruising along. I just said like the notes look long, but they really are not. Okay, so last up we have, of course, quotient. So write the quotient in standard form, A plus BI. So a couple things that are significant there. In standard form, we don't have, of course, this crazy fraction with an I on the bottom. You can't have an I in the bottom of a fraction. Because remember, I is really a square root, the square root of -1. We can never have radicals in the bottom. So I'm going to use the conjugate. That's why I was prepping you with that conjugate spiel. 4 plus 5I. Because then we'll get a nice, pretty, simple, boring number. But of course, I got to do the top. So I'm going to multiply these together. 4 and 4. 4 and 5I. Now on the bottom, we can kind of shortcut it, because remember the middles will cancel. 4 and 4. Negative, positive. 5 and 5. I and I. And I squared, we know by now, is a -1. So what number do you really have on the bottom? Because you're going to have 16 plus 25, which is 40. Now I'm going to do one last thing. And this is a nitpicky thing. Remember the order, A plus BI. So my real part is 16 over 41. My imaginary part is 20 over 41I. Algebra 2 might have let you leave it at this previous step, but really we should have A plus BI in standard 2. Okay, more of the same. Now the top I don't care about, it's the bottom you can't have the I, the radical really. So I'm going to use the conjugate. And I'm kind of making a face because I'm like, oh gosh, we got a lot of, long fraction brother, a lot of foiling on the top. 8 and 1, 8 and 2I, -7I and 1, -7I and 2I. Now, of course, the bottom, same spiel, middles will cancel, 1 and 1, -2I, -2I. Whoa. Okay. I squared, of course, -1. So my -1 and -14, that's really a plus 14 there. So So I'm going to combine 8 and 14 together. 16 minus 7i, let's put the i's together, 16 minus 7. And what number do you have on the bottom? 5. I squared negative 1, that makes that a plus 4. Now we're going to split it because I want my distinct real part. So I've asked you for the real part, 22/5, and our imaginary part. Any questions on that? These are the most time-consuming ones, is all the foiling, of course, and the simplifying. But really, that's not that bad. Okay, last one, or getting to the last here, getting to the end. So, of course, the I on the bottom is an issue. So, what are you going to multiply by to get rid of the I? You could do I, you could do negative I. Either of them will lead us to the right path. It doesn't matter. I heard I first. Because what's I squared, really? Negative 1, which I'll make that a negative 1 in a minute. I'm going to multiply all the 6 and I together. So many i's. So I already said the bottom was really a negative 1. Let's clean up the top. Negative 1 with the negative 7 is going to make that a plus 7. So I got a couple things I'm going to do before I put a final answer. Order. I want the real first and the imaginary. And I don't like that negative on the bottom. So what is your best final answer? Correct order, correct signs. What's your real part? Negative 7. 7 over negative 1. What's your imaginary? Minus 6i. Got it. Any questions on that guy? All right. Home stretch here eventually. Write the following in vertex form. Hey, this is really just a review for your quiz tomorrow. I thought I'd throw this on. You're welcome. Okay, vertex form. Remember, is the green one over there. You need that quantity squared. You're in standard form. So I'm going to get that quantity squared by completing the square. I'm going to subtract 2 over. I'm going to get it out of the way. I'm going to write f of x as y, just a little less writing. Now, one little glitch here. To complete the square, the lead coefficient should be negative 3. Your choice is, I could divide everything by negative 3, but I'm like, man, that's going to be a lot of fractions over here. Or because we know our vertex form, you have that coefficient in front, I'm going to factor out negative 3. So a little mental math here. Negative 3 times negative 2, positive 6. We're going to add our new term to force it to factor. All right, complete your square in 2. Half of 2.
1.
Squared. We're going to be super conscientious, though. I'm not putting plus 1 over here. I'm really putting what? I heard minus 1. I heard 3. Negative 3. Because negative 3 times 1, negative 3. So that's really what we're balancing out. I'm going to total that up over there, negative 5. I'm going to factor this, multiply to 1, add to negative 2, negative 1, negative 1. Last but not least, we're going to add the 5 at the back. I'm going to put the final answer up here so it's not clear at the bottom. And now if I asked you for the vertex, you could tell me it is 1, 5. How's it going to open? Down because of the negative lead coefficient. All of that fun-filled stuff from, the beginning of chapter 2. Any questions on that guy? Okay.